Very warm welcome to everybody for the fourth session of BCBR course organized by the AIMS Mohali. I'll be talking about measures of disease frequency. So we'll be talking about measures of morbidity and measures of mortality. Measures of morbidity include incidence and prevalence, whereas measures of mortality include case fatality rate or case fatality ratio and disease specific mortality. So this is the overview of this presentation. We'll familiarize you with terms like cumulative incidence, incidence density, and point and period prevalence. So what are the measures of disease frequency? Measures of disease frequency characterize the number of persons in a population who become ill, that is incidence, or who are ill at a given period of time, that is prevalence. So this can be likened to the analogy of a bathtub, also called the epidemiologist's bathtub. The incident cases are represented by the water that is incoming into the tank. The prevalent cases are the water that is standing in the tank. And the deaths, emigrations, and recovery are represented by the water that is draining out of the tank. And this water actually represents the disease burden. So incidence is the number of new cases at a given period of time. The term that is used is cumulative incidence. So cumulative incidence is the number of new cases in a given time divided by the population at risk at the same period of time, usually taken at the start of the time. And this is multiplied by a multiplier that is 10 to the power n. And this is based on the choice of the person who is conducting the study. If it's the numerical value of the ratio is very, very small, then the number can be high, like it can be 1000. So if it is 0.002 cases per 1000, like per a population, then it can be multiplied by 1000 to make it 20. Cumulative incidence is also called attack rate. Another term that is used is called incidence density. That is, the numerator remains the same, number of new cases in a given period of time divided by person years in the same period of time. So here time factor is included in the denominator as well. And this is again multiplied by a multiplier. So if represented pictorially, this square represents the time frame. The red dots represent the onset of the disease. The arrowheads represent mortality due to the disease or death. So what is the incidence of the disease? It will be the number of new cases in a given time frame. Say the disease is cancer. It's a long-standing illness. So T is over 10 years. 2, 4, 6 are the incident cases. Total number of population at risk is not 1 because 1 already had the disease at onset of the time period. 2, not 3 because 3 already had death before onset of time period. 4, 5, 6, 7, and 8. So the denominator is 6. So incidence is 3 upon 6 into 100, that is 50%. So that is our incidence. Please note that incidence is a dynamic figure and it varies with impact of prevention programs, varies with environmental factors. So it gives you the trend of the disease and it also gives us the impact of prevention activities on the disease. So coming to the next term, that is prevalence. Prevalence was represented by water standing in the tank, representing the disease burden that is already there in the population. It is of two types. Point prevalence is the current cases, that is new and pre-existing at a specified point in time, divided by population at the same specified point of time. Whereas period prevalence is the current cases, new and pre-existing at a specified period of time and divided by the average mid-interval population. So point prevalence is a thin cross-section of the time period, whereas period prevalence takes into account the whole time period. So coming to the same figure, here if we have to calculate the prevalence or the point prevalence at this cross section, then the total number of cases during this point of time are 2 and 6. Total number of population at this point of time are 2, 4, 5, 6, 7, and 8. So 6. So prevalence will be 2 upon 6, that is 33.3%. And please note that anything that causes a shortening of this arrow will actually lead to a decrease in the point prevalence. So a high cure rate, low case fatality, etc. will lead to a decrease in prevalence. So factors affecting prevalence are prevalence is increased in case of long duration of illness, increase in new cases, immigration, improved detection, and emigration of healthy people. Whereas the converse is true, causing a decrease in prevalence if there is a shorter duration of illness, decrease in new cases, emigration, improved cure rate, and immigration of healthy people. So coming to the measures of mortality, basically we will talk about two: case fatality ratio and disease specific mortality. Their numerators are same, only the denominators are different. Case fatality ratio is the number of deaths in a given time divided by number of new cases in a given time. And it reflects the severity of an acute infection. And remember, it is not case fatality rate, it is a ratio because time does not factor in the denominator. Compare this to disease specific mortality, in which numerator is still the number of deaths in a given time, but the denominator is the population at risk at the same time. So it gives us the burden of the disease in terms of number of deaths. And this is different from case fatality ratio by its denominator. So take home message is that prevalence is a static measure of disease burden. It does not factor in time. Incidence is a dynamic measure of risk over a period of time. Mortality, that is disease specific mortality, has population as the denominator and it reflects burden due to mortality. Whereas case fatality ratio has cases as denominator and it reflects severity of an acute disease or acute infectious disease. So thank you very much. I hope this helps. We will meet in the discussion tomorrow. Thank you.